Back in 1960, two men achieved what seemed impossible. They descended to the deepest point on Earth, the bottom of the Mariana Trench. It was a breathtaking triumph of courage and engineering. The world celebrated the feat, expecting a new era of discovery. Instead, after the applause faded, something strange happened. We stopped going back. Subscribe for more deep ocean mysteries grounded in real science and history. Why would humanity conquer the most alien place on its own planet and then abandon it for decades? The answer isn't simple. It involves crushing physics, terrifying risk, enormous cost, and the unsettling experiences of those first explorers who entered a darkness deeper than anything humans had ever faced before. To understand why exploration stalled, we need to grasp how monumental January 23, 1960 truly was. That day, U.S. Navy Lieutenant Don Walsh and Swiss oceanographer Jacques Piccard climbed into a 7-foot steel sphere suspended beneath a gasoline-filled float, the Bathyscaphe, Trieste-bound for the Challenger Deep. The descent took nearly 5 freezing hours. They sank beyond sunlight into eternal midnight. Inside the cramped sphere, instruments glowed faintly while temperatures dropped. Outside, pressure climbed to over 1,000 times surface level strong enough to crush a submarine like thin metal. During the descent, a violent crack shattered the silence. An outer plexiglass window fractured under pressure, sending shockwaves through the vessel. It was a chilling reminder that the ocean floor was not meant for human visitors. One structural failure would mean instant destruction. Yet they reached 10,916 meters, nearly 36,000 feet, and gently touched the seabed. For 20 minutes, they gazed into a world unseen by human eyes. In their lights, the ocean floor appeared covered in fine sediment, not barren but layered with organic remains. Most astonishing was the presence of life. They reported seeing shrimp and what Piccard described as a flounder-like fish. Complex organisms thriving in crushing darkness defied scientific assumptions. Even in the most extreme environment on Earth, life had found a way to survive. Their return was historic. Like summiting Everest or landing on the moon, it marked a defining human achievement. Many believed this was only the beginning of systematic deep-sea exploration. But instead of expanding, the effort faded into decades of silence. The silence wasn't caused by indifference. It was caused by physics. At the bottom of the Mariana Trench, pressure exceeds 16,000 pounds per square inch. That's comparable to balancing several armored vehicles on your thumbnail. Any structural flaw results not in leakage, but catastrophic implosion. For decades, the technical challenge proved overwhelming. Even with modern engineering advances, the risk remains extreme. A powerful example came with the loss of the remotely operated vehicle Nereus, once a symbol of deep-sea technological progress. In 2009, Nereus successfully reached the Challenger Deep, becoming one of the few vehicles since Trieste to do so. But in 2014, while exploring the Kermadec Trench nearly 10,000 meters down, communications suddenly ceased without warning. Debris later surfaced. Nereus had imploded under immense pressure. Its destruction was instantaneous and total. The tragedy deeply impacted the scientific community, as it had been the only vehicle of its class available internationally. The lesson was sobering. The deep ocean does not discriminate between human and machine. It destroys both equally. This ever-present, unforgiving danger became one of the strongest deterrents to sustained exploration of the planet's most extreme depths. Beyond physical danger lies psychological strain. The deep sea is an environment of total darkness, freezing temperatures, and overwhelming isolation. Explorers depend entirely on fragile metal shells, cut off from natural senses, suspended in a place fundamentally hostile to human existence. Adding to the unease are unexplained sounds. Hydrophones lowered into trenches have recorded strange noises for decades. In 2014, researchers captured a bizarre signal nicknamed the Western Pacific Biotwang, a sound unlike anything previously documented. The recording began with a low rumble before rising into a metallic screech. For years, scientists speculated about its origin. Some considered volcanic activity, others unknown marine life. Its strange, almost mechanical tone fueled mystery and fascination. Only recently did analysis confirm it came from a unique population of Bride's whales using a regional vocal pattern. Yet for years, it remained an unsettling reminder that the deep holds secrets difficult to interpret. Another famous mystery was the bloop, recorded in 1997. Its immense low-frequency signal was detected thousands of miles apart. While later attributed to cracking icebergs, initial speculation imagined colossal unknown creatures. These mysteries, combined with isolation and danger, created a psychological barrier. The abyss wasn't merely difficult, it felt alien and deeply unsettling. Fear, even subtle and unspoken, contributed to humanity's retreat from its deepest frontier. The long pause in deep exploration wasn't caused by a single factor. It resulted from a convergence of catastrophic risk, staggering financial cost, and shifting global ambition. Together, these forces created a practical and political barrier. Failure at nearly 11,000 meters is not a setback, it is annihilation. Repeated dives strain materials to their limits. Even the strongest engineering solutions exist under constant stress from extreme pressure. The financial burden is equally daunting. Designing vehicles capable of surviving hadal depths rivals the cost of space missions. During the 1960s, global attention shifted upward toward the space race, where political prestige and funding were concentrated. The ocean floor lacked the dramatic appeal of lunar landings. Scientific returns seemed less immediate, less glamorous, and less geopolitically powerful. Governments prioritized space, leaving deep-sea exploration comparatively underfunded. Practical access also mattered. Reaching 6,000 meters already allows exploration of about 98% of the world's seafloor. Pushing deeper to access the final 2% demands exponentially greater cost and risk. This combination extreme danger, enormous expense, and strategic redirection towards space explains the decades-long silence. No mythical discovery drove us away. It was a rational, if disappointing, decision shaped by economics and survival. For over 50 years after Trieste, no human returned to the Challenger Deep. The silence finally broke in 2012 when filmmaker James Cameron piloted the deep-sea Challenger to the bottom during a solo expedition. Cameron spent 3 hours collecting samples and filming the abyss. His mission demonstrated what private initiative and determination could accomplish, even without large-scale governmental programs driving systematic exploration. Beginning in 2019, explorer Victor Vesovo conducted multiple dives in his submersible limiting factor. His expeditions reached depths exceeding 10,900 meters and mapped the trench with unprecedented precision. Vesovo's missions discovered new species and expanded scientific understanding. Yet he also encountered plastic waste at the ocean's deepest point, a stark reminder that even the most remote environment on Earth is touched by human impact. Today, deep exploration is driven less by governments and more by determined individuals. These modern pioneers continue where Walsh and Piccard began, but large-scale, sustained programs remain limited compared to other scientific frontiers. So why did we stop exploring the deepest part of Earth? After a heroic beginning, reality intervened. Crushing pressure, catastrophic risk, immense cost, and global focus on space exploration pushed the ocean's depths to the margins. Yet the story isn't over. New expeditions have revealed thriving ecosystems powered not by sunlight, but by chemical reactions from the seafloor. Life in the abyss is more complex and resilient than once imagined. Much of the Mariana Trench remains poorly mapped. Countless microbial species are still unknown to science. The hadal zone represents an immense frontier of biology, geology, and chemistry waiting to be understood. We didn't abandon the deep because of monsters or mysteries. We paused because it was difficult. Now, as technology improves and curiosity returns, the question is no longer why we stopped, but what we will discover when we dare to descend again.